Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Ashley, who has just completed the course Linux Basics for Robotics, and she'll be giving us a presentation on that. So without any further ado, let me now hand over the platform to her so she can begin her presentation. Alright Ashley, whenever you're ready.
Thank you. Thank you very much. And hi, everyone. First of all, thank you for your time. And I hope you enjoy my presentation. So I'll start connecting to the real rock.
All right.
And
yeah, it's taking a bit long, but yeah, wait for it.
yeah, maybe it's my network connection, but I don't think so.
Yeah, no worries.
Okay, so here we are. Let me know if you can see the stream in my screen.
Yeah, we can see it.
Okay. Perfect. So I'm just gonna go ahead and open a web shell, and I'm gonna run the teleop code. So just 1 second, I'm gonna pull up the commands. Okay. So here we go. Okay. We have this in here. Can you see the new screen?
Yes, your RFS window, yeah, we can see it.
Okay, perfect. So I'm just gonna run this. Okay. And I'm just gonna try to move it forward. Okay, so we're fine. I'm gonna check if everything is working. It appears like it is. Okay, so right now I'm gonna start running the programs that I made in the project. So the first one is I'm gonna redirect to where my programs are located and wait for this to tell me that it's ready. Okay, we're fine. And I'm gonna open the main program that it's the obstacle avoider. Okay, we should be fine in there. And finally, I'm gonna open the statistics program. And we should be fine in there. Okay, so well, as you can see, it pretty much does the job when it detects that it's going to be near or close to any obstacle or wall. It will stop and it will correct its course. Sometimes it scares me a little bit because I feel it gets too close to the wall, but it always redirects himself.
All right. What threshold values did you use? So how close to the wall does it has to get to?
0.3. 0.3.
Okay. All right. Yeah. So should be working correctly then.
Yeah.
0.3. Okay. All right. I see.
I just took I just got it myself with the simple patrol code, and that's the threshold that wasn't there, so I used the same one.
Okay, all right.
Oh, sorry.
Alright, it seems to be doing well at avoiding obstacles, so that's good.
Okay, should I stop it there or should I leave it running a little bit more?
No, it's fine. I think you can stop it now. So
Okay, so I'm just gonna. Oh.
just hit dismiss. It's okay.
Dismiss. Okay.
Yeah.
Thank you. Okay. This one, and we should be okay. Okay, so can I disconnect from the robot?
You want to show the simulation? Okay, yeah, you can disconnect, and then after this you can then go through your presentation.
Of course.
Yep.
Okay, so now I'm gonna start the simulation, which works basically the same, but simulation.
Yeah. Would like to talk about the differences that we found. So after this demonstration, we'll do like you have to ask you some questions to just find out. Okay, what did you notice is the differences between the simulation and the real robot? And so I'll allow you to run it, and then we can talk about it later, just after you finish your presentation.
Of course.
All right.
Okay, so we should just wait for the other one to boot up. Okay, here it is. Okay, and I'm gonna basically, well, do the same that I did last time. Okay. So it should start working.
So I see that it does stop after the initial movement. So can you explain to me what's going on there? Does it move a particular distance before resetting the parameters to a different value? What's going on there?
Can you repeat the question, please?
So you did notice that after it started moving for the first time, right? So from the initial position where the robot was spun, right? It moved a couple of I cannot say meters. Okay, let's call them meters here, assuming that we are using a meter scale, right? So it moves for a particular distance and then stops, right? Usually at the very beginning. So what I wanted to know is, can you explain to me what's going on there? How does your algorithm work? Does it stop the robot before setting the parameters to different values, or does it stop to take into consideration what is the readings that it is getting from the sensor, from the laser scan?
So in that case, what I try to do was basically for it to scan if he's able to, move forward or move to the left, to the right. and in case he's not able to because of the distance measurement, if it detects that it is too small or less than the threshold, then it will not move. In case it detects that it is able to move, then basically a distance will be calculated based on the measurements, and the movement will last for the amount of seconds that results from that calculation.
Oh, okay. All right. Yes, very well done. All right, I see. All right, so it's going to probably do the same thing. Okay, I see. All right, and then setting parameters again. Okay, so I think with what we've seen, this is good enough. So I'd like you to get into your presentation. If you're going to use any slides, you can do so now. So you just have to terminate your program, and then let's get into the details, and then you can be showing your code as you go. Then we'll look at what you did and also try to understand the logic behind it.
Of course. Okay, so let me just close this so we can have this one in the big screen. Okay, so well, I wanted to quickly go through the parts that the project consisted of. So well, the first part really was pretty straightforward because I was just getting to know the robot and how it worked, how to launch the animation. So it was pretty much just basics. And okay, for the second part, this is the part where I had to create the setter and getter functions, and I had to copy and paste just move the programs of the robot interface and simple patrol. But specifically for the robot functions, well, I believe that it was pretty straightforward as well, because I already had the instructions. For example, in here, it already indicated to me that I just had to change the parameter name in this space here and in this space here. And I just had to use these specific functions that they were already providing to me, which will be able to let me know, the distance or the pitch, yaw, and roll. Yeah. Let me just check. Roll, pitch, yaw, and roll angles for the robot. So I believe that this was pretty much straightforward, just changing the parameter names for the getters, and well, the same for the setters. And the next part, which was where I got to implement my own algorithm, at least for me, it was pretty much straightforward as well, because I already had the instructions in here, so I was able to easily follow through them. So let me just open this one. Okay, so here it is. And for example, for getting the measurements, it was pretty easy, right? Because I already had the functions that allowed me to get them. And in the case of the logic for the actual movement of the robot, I got it myself a lot with this code, the simple patrol bash. So for me, it felt more like I was guiding myself. So I just had to be careful, with the if statement structures, to make sure that I indented them correctly and that I closed the if statements whenever it was needed, because I knew that could affect the logic on how my robot will move if I didn't do that correctly. And one challenge that I faced with this part, I believe that it was a pretty novice challenge because when I got to check if any of the angles was free or not, I was trying to do this, instead of realizing that this is actually a Boolean value. So I just needed to do that. So the first time that I tried my code in the simulation, my robot, it just turned around. It never moved forward or backward or anything like that.
Yeah.
And well, I realized that it was because of this. But yeah, for checking if any of the angles, and then I can let it know if I want to turn left, turn right, or actually move forward. And this is something that I do with all of the 7 cases that were presented to us in the pseudocode.
Okay.
So yeah, this was the case for this part of the code. And like I told you, it actually calculates the distance to move and the time to move based on those scans. And the threshold that lets him know, look, you're too close to the obstacle, do not move. And for the last code, that it was the robot statistics, well, it actually was straightforward as well, because the pseudocode really helped me a lot for the logic. And one challenge that I faced in here is actually that I forgot that this is not Python. So I was trying to do print distance and the variable. And then, well, I remember that this is not Python, and I changed it to the echo command. But yeah, again, this was pretty much straightforward, just using the functions that I had already defined in the robot functions algorithm and just printing them.
All right. Thank you so much, Ashley. Okay, so now would like to get into some questions, since this is Linux for robotics, right? So there are some general things you're supposed to know about Linux and how to work with in the terminal. So I noticed that you've been copying and pasting a lot of commands, right? So what I would like you to do is, can you open your terminal and navigate to like a certain directory, for example? So you can open it now, and then you can navigate to your workspace, right, to see the packages we've got. So for example, yes, so let's go to the ROS2 workspace, for example.
Okay, so it should be ROS2 S. Okay.
Yep. And then can you list what is in that directory? We want to see what's in there.
Okay. Do you want like permission details or just the normal?
Just the normal listing. So let's assume we are trying to figure out what is in there. Okay, so that's the ls command. Okay, now I want you to go into the src folder.
Okay, of course. So I have on my, okay, so I should just do.
Then let's list what's in there again. Okay, we've got our Linux basics project. Okay, let's get into that directory, and then we list again the files that are in it.
Of course.
Okay, so that's good. So let's assume that you want to see the contents of like setup.py in the terminal. How would you do it? Right, without using the IDE. Okay. Yes.
Stop. Okay. I got scared there a little bit. Okay. I was like, why didn't it work?
Yeah, okay, there we go. Yes, so you can either use, so that's a shortcut for Vim, or you could use like cat, because if you just want to see, you're not going to edit, you could also use cat. But anyway, that's good. Now, if you are going to make any changes to this file, what are the things that you need to do? So can you do the process and explain to me what you will be doing? So right now,
yes, of course. So
go ahead. Yes.
Okay, yeah, so I would need to go into the insert mode, which I got into just by pressing the letter E in my keyboard. And well, now I can actually edit what's in here. So for example, let's say I just want to add a letter, for example. If I wanted to save these changes, I would need to press, do I save them or do I just explain the process?
So let's say you wanted to save, right? How would you do it?
Yeah, so I would just need to press the escape key in my keyboard, and then I would need to do quit write. Oh, sorry. Okay, quit write. No, sorry, it was um I forgot how that's
W
in English. Sorry.
W.
No,
Yeah, the other way around.
Yeah. Okay, yeah.
Is W before Q anyway, but yeah, you got it right. So that's the process I wanted to find out if you understand that. So that is good. All right, so now this is just conceptual. Can you tell me the levels of permissions that we have got in Linux, right?
Yeah, of course. So we have the read permission, the write permission, and the execute permission.
All right, wonderful. Thank you so much, Ashley, and thank you so much for getting the courage to come and make your presentation here. And I would like to wish you all the best for the coming months. So we're gonna wrap it up here, and you just hang around for me, okay?
Oh, okay. Thank you very much for your time.
All right. Alright everyone, this was Ashley's presentation and a warm congratulations to her. I'd like to encourage all those of you who want to try out this course, and to do so, then you can come here and showcase your work, as we believe that teaching someone or making a presentation about whatever project you've worked on is the best way to show your understanding. So until then, keep pushing,